Okay, here we're back talking about sedimentary rocks. We said in order to form sedimentary rocks, there's four things that have to happen. The first thing, there has to be weathering. In other words, breaking rocks into small pieces and little pieces off. This can be soil particles, smaller pieces of rock, gravel, things like that, size pieces, so forth. Physically, things break down rocks like ice. Getting in cracks and freezing and expanding and cracking it more and more and breaking off pieces. It can split whole rocks, whatever. It can be rocks banging together as they get washed down the river, falling down in a landslide, going down the thing, down the side of a hill or something like that. All those will work. Chemical has to do with chemicals that react with it. Some of these things that could happen with some of that can be water washing through and things in the water reacting with it. If you have acid rain, for example, that might eat away at the rocks even a little faster than normal. Lichens are little critters that look like little patches of green or kind of cream colored a lot of times on a rock. So you'll see this rock and there'll be this little patch of kind of green or yellow colored stuff. Okay, and it just looks like it's growing on there, and that's actually a fungus, which is like a mushroom, and it's also like a algae growing together. And whenever it rains and gets wet, it starts to grow, and it secretes acid, and the acid breaks off little pieces of the rock. And so even though it's just sitting there on top of it, looks like a little colored plastic thing stuck on there, it's actually eating away at the rock little by little. Not very fast, but little by little. Okay? Now, once it's been weathered, then it has to be eroded. It has to be carried away to somewhere else. So erosion is the next one. Okay? So this involves the idea of movement. Okay? The weather particles are moved or transported. Moved or transported somewhere else. Okay, so this is the act of carrying them somewhere else, and this can happen by water. Once again, water erosion when it rains, like the big rains we just had. Always a lot of soil being carried downstream and stuff by that. It can be wind erosion, especially out west. There's a lot of rock formations are shaped by the wind wearing off and eroding away at sandstone. And could be, if you're farther up north, glaciers and ice can do a lot of that also. Okay, so this is actually, so first the little pieces have to be broken away. That's weathering. Now they've got to be carried off somewhere else. All right, now after erosion, the next step is deposition. They have to be deposited somewhere. They have to be put somewhere. Okay, once they've been carried from where they're at, they're going to be deposited. Generally, for example, with water, if it's going fast, then it's going to carry the soil along with it. But when it has to slow down, it dumps a lot of that. For example, in flooding, a river jumps its banks, it floods, it goes out here and it spreads, and then when it gets off the river, it slows down and it dumps all this dirt, and that's why you talk about people's whose houses are filled with a foot of mud or silt and stuff like that. That's the depositing. Whenever the wind, water, or whatever's carrying the soil slows down, then it dumps those or deposit those layers somewhere else. Okay, and we can tell the order they were deposited on. When you look at a rock layer, you have these different layers. Whatever's on top was deposited last, and whatever is on bottom was deposited later. So very often we have these layers, which we'll talk about later. Okay. Sometimes they're sorted. For example, on the beach, it tends to be all big grains of sand because all the little grains have been washed back out by the water every time. Sometimes you get a mixture of all kinds of sizes all mixed together. All right. Now, once they've been deposited someplace, they have to undergo what we call sedimentation. Sediments are just the things being carried. So sedimentation, okay, and this is kind of similar to deposit. In other words, they have to be put in rows here, in layers. The idea of having them in layers like this, okay. But there's also two other things that happen in order for it to be considered sedimentation. You have to have, one is compaction. All right, as you get more and more layers pushing together, they get squished together, and they get tighter and tighter and squished together. All the spaces, air spaces get pushed out and so forth, and they get pushed down tighter and tighter. Okay, and it squeezes out any extra water that might be in there, any air spaces and so forth. And the other one is cementation. Okay, they have to be cemented together, usually by other minerals such as silicon XSO2. That's basically what's in quartz. Sometimes if it's like limestone or something, it'll be calcium carbonate, which is kind of like what limestone is basically made out of. Sometimes in reddish rocks, it'll be iron oxide, which is kind of like a rust-looking thing, and that helps glue the sediments together, and that's very important. I have some sandstone rocks that I put in my yard. Thought these would be great. They look really pretty, kind of a nice gray color and everything, and you picked it up like a big chunk of rock, but they had been compacted enough that they stuck together. But when I stuck them home in my flower bed, as it rained and various things happened to them, they just dissolved and turned into a big pile of sand. Why? Because they had not had this cementation. Okay, they did not glue them together so that they would hold together, just like a block of cement, basically. Now, once you've formed the rocks, okay, by these different layers, little pieces broken off, they've been eroded, carried somewhere, deposited somewhere, and then compacted and cemented together so that they can we have our sedimentary rocks. And there are two main categories of sedimentary rocks we want to talk about. The first one is clastic. Okay, not classic. Yes, it's a classic sedimentary rock, but it's clastic. Okay, and this is basically made of pieces. That's really what this basically amounts to. I'm not sure if that's what the word means literally, but it's little pieces. Okay, weathered rock. Okay, weathered is not spelled right. Sorry, weathered rock. It could be pieces of shells. If you're in an ocean environment, a lot of rocks you see, limestone stuff that has a bunch of it's mostly just a bunch of layer of shells and stuff. Other kind of debris and maybe organic matter. All right, and these are classified primarily by the size of the sediments that are in them. The size of the sediments. Are they big pieces? Are they little pieces? And so forth. Okay, if they're very, very small, they would be made out of shale, which is the very smallest particles. Okay, and these would be things like silt or clay. You hear about clay soils. We have a lot of clay soils around here. Silt and clay, very small. You look at them, you can't actually see the little grains in them. Okay, larger soil particles would be sand. So this is going to be sandstone. Okay, sandstone, you can actually see the little grains in it. Okay, and you can see the visible. So I'd say they're visible grains of sand. So that would be the next size. Now if it gets larger, even point you have gravel and big pieces of rock that you can see, that would be called a conglomerate. Okay, a conglomerate just means a combination of a whole bunch of things put together. So it's a whole bunch of little pieces of rock put together to make a big rock. And it can be rounded. If all the pieces are smooth and round like pea gravel, then that shows us that they have been eroded like in a stream or something where they've been rounded off. Okay, they can also be angular, which means sharp edges and stuff, which means they haven't been carried or eroded by water very much, and they probably just broke off of bigger pieces of rock and are still right where they came from. All right. So since sedimentary rocks are made of sediments, it makes sense that a lot of them are these clastic rocks. Now the other group of rocks would be chemical rocks, chemical sedimentary. Chemical sedimentaries are primarily ones that have formed from precipitated minerals. In other words, they were in solution in water and they just settled out at the bottom. Okay, and they settled out of this either could be because the water evaporated and left them behind. A lot of salt rocks and so forth. Salt rocks, halite, gypsum is another one. Okay, a lot of those minerals just happen like that. Okay. Others may be chemical reactions. In other words, they reacted with chemicals in the water and they formed one that's solid and would sink out to the bottom. Okay, a lot of times calcium carbonate, which is like limestone and stuff, may do this. Okay, in fact, a lot of these rocks are called carbonates. Okay, because they contain calcium carbonate, magnesium carbonate, and a bunch of these other carbonate. And some of these are also made from little tiny skeletons of little tiny microscopic sea creatures and stuff like that. All right, speaking of which, one of the main characteristics of all these rocks are sedimentary rocks are the only rocks really where we're going to find fossils. Since they're deposited layer by layer, as things get buried underneath it, then you're going to see these, okay? And so this is a good place to look for those fossils and stuff, where they don't get destroyed and then they get covered up and compacted along with the sediment. Some example of fossils, for example, here's petrified wood, which you see minerals have replaced it, and that's usually it falls into the ground and it gets covered up by minerals, and the minerals leak in and take the place of the rock. Okay, you can see here an imprint left behind of a fish. Sometimes it's just an imprint. Sometimes it actually fills in like the shell of an animal like this. It gets filled in and leaves the imprint of what was the mold, if you will, that was left behind. Sometimes plants, for example, are very often known just to leave a small imprint of carbon that leaves this printing of what the leaves look like and so forth. But various kind of fossils are very often found in these. Later we're talking about igneous rocks. Obviously, we talked about igneous rocks already. They obviously are going to be so hot, any fossils that might have been them are going to be melted and destroyed. And metamorphic are ones that change by heat and pressure, and once again it's going to destroy most of the fossils if there's anything in them. So sedimentary rocks are a chief source of fossils that tell us what things used to live here and so forth in the past. Alright, I noticed I forgot to tell you about this one here. This one looks like an ice cave or something like that, but these are actually evaporites. These are water solutions that drip these minerals here, and they've solidified behind it. Like I said, it looks almost like ice or something like that, but it's actually where water contained minerals, and water dissolves away. And just like icicles on your house get longer and longer as they freeze, well, these get longer and longer as they leave deposit behind. And you can see, very impressive in this case. So we have igneous rocks, we have sedimentary rocks, and the last one we have is metamorphic rocks. Metamorphic, meta means to change, morphic means shape. So these are rocks that have been changed, or they've changed their shape, and they've basically been changed by two things, either heat or pressure, and usually actually both, heat and pressure, okay, in different amounts. Alright, so we're talking about metamorphic. Okay, now, notice we say they do not melt. If they melted, then they would actually be igneous rocks, if it completely turns to a liquid. But very often, if you have lava that comes up into an area, it touches these rocks around it, the border here where it says contact border, and basically it's going to heat those rocks around it and change those rocks. These here where the lava is, those are actually igneous rocks, but these rocks that are changed by the heat are going to be metamorphic, okay? Same kind of thing here. If a granite shoots into an area, then it's going to get really, really hot next to it and then cool off as you get farther away. But those rocks next to it may not be completely melted, but they will be changed, okay? And they will be changed enough that they can either be stretched, basically deformed, if you will, okay? So they're either going to be stretched or they could be compressed, stretched or compressed, okay? Sometimes the layers get pushed even closer together, kind of like we talked about happened in sedimentary, but even to more extreme. They may recrystallize. Even though they don't actually melt, the crystals may change and reform as different kinds of crystals. Okay, we tend to think, oh, it's got to melt to change its crystal, but actually, if there's enough heat and pressure, it can cause it to change, even though it doesn't technically melt. Okay, crystallization. It can recrystallize, and so it causes it to form new minerals. And basically, atoms may migrate through that heated rock to make big crystals, or they may recombine and just make different crystals. So either the crystals may get larger, they may change into a different kind of crystal, different shape of crystal, all those kind of things, just from the heat and the pressure that is on it. Okay. Now, we talk about the deformation. A lot of that is mechanical. Okay, we kind of talked about this already without actually labeling it, but mechanical deformation is when there's actually forces pushing on it, pressures and stuff like that, that either put stress on the rocks in some way. It may have heat or it may not. Sometimes you may see rock formations on the side that ripple like this. Basically, there's pressure put on it and it causes them to buckle or make this rounded shape. Okay, and so you'll see that change in the shape of the rock layers, and that would be mechanical forces. Okay, it may cause them to flatten. Okay, they could get pressed another way, which causes them to flatten out more. Okay, but that's primarily from pressure. The heat, on the other hand, is where you have what we call contact metamorphism, where it touches these hotter lava or granite outcroppings. And we're not quite finished, almost there, but we're just going to finish this up in the next video.